We can now move to the second exercise, where we repeat the steps which we did in exercise number 1, but with the difference that today we will not use the memory manager with the discovery functionality, but we will create the custom driver by ourselves. This is useful in case that your external memory don't support this discovery feature. So I want to show you how to create your own driver, what you need to get from the memory datasheet, and how to work with the API and what to fill to make it easier for you. So what we will do, we will use the completely same setup. We will still use the Nucleo. We put the small application into the external memory, which will toggle the LED. But the difference will be that now we will use our custom driver. We can start creating new project in the CubeMX. This will be just a repetition, so again we will type H7S3. We will select the same as the Nucleo, where is the Nucleo, the complete empty project. Again we want to create the MPU configuration. I will do the same step like before. So I will enable the PD13, which will be our LED, and I assign it to the application. Now I will set the MPU. I will not use the MPU inside the application, but I will use the MPU configuration inside my bootloader. So I will enable both caches, and I will create one region for the 90 million 9 and 7 zeros. The size will be size of my memory, which is 32 megabyte. I want to access the read access or the read access and unprivileged access, it doesn't matter. And the cacheable and bufferable to get advantage of the caches. So now my boot and the MPU is configured. And I can go to the XSPI. I will again use the XSPI 1. I'll make it a little bit bigger. I will use for the bootloader and for the external loader, like the before. I can here use the OSPI mode, even if I will configure it as a normal SPI. I can still reserve the pins in case that you in the future want to switch into the OSPI. Otherwise, you will switch the standard SPI to save the pins, of course. We have the port 2 and the chip select 1 on port 2, so you should have this shape. Again, the same configuration I like before. The mode is Macronics, the size is 256 megabits. The chip select that time is 2. Website is nothing, no prescaler, no sample shifting. Sample shifting yes, because now I will use only standard SPI mode, so I want to use this feature. And rest should be okay, yes. Now I can go, not forget the SBS unit to enable high speed low voltage, because I'm still running on the low voltage. So I will enable it in the bootloader and inside the external loader. And for the port 2, so the middle one. If you forget on this, communication will start failing, usually on the higher speed. If you run only 20 megahertz, you will not recognize it if you enable this feature or not. And I forget one thing, the RCC here set the LDO supply. And now I can finally move into my external manager. I will use the external memory manager for the bootloader and for the external loader. I will activate it. I definitely want to use the execution in place. And for the memory, I will not use the discovery protocol this time, and I will use the user. So I will be my own creator of my own driver for the memory. For the external loader, I will activate the external loader because I want to create the external loader too. For the memory 1, for the toolchain, I can name it exercise 2 loader, for example. Be careful now, he is not filling the address for us because he is not sure where the memory will be located, so don't forget to fill this address in the code. So I will do it when we go into the code. The number of sectors is 8192. Sector size should be 4096. Page size is 100 and the arrays and the programming time, it's okay. There is nothing to set. And I believe we have everything from this part. Let me just check. Yeah, I believe that's everything. And we can go to the clocks. So go to the clock configuration. I will again set the device to the maximum speed. Give him some time to find the correct configuration. Now, important thing for our clock configuration for the XSPI. If you remember when we used the datasheet, the maximum speed for the standard single SPI is only 133 MHz. So I will set the similar speed as close as possible to this one. I am not able to set the 200 if I am not using the Octo SPI mode. As a clock source for my XSPI, I will use the PLL2. I can, for example, here set the divider by 8, and I will use the multiplier by 80 and divided by 5, I believe, and I get 128 MHz, which I am fine with this value, which should work perfectly for us. We can go to the project manager. We can select the Cube IDE. Don't forget to check the external memory loader project. And I name it exercise 2, and I will let generate the project. So he generated my project, so I can click open the project, and he should be able to add it into my Cube IDE.